So what does it mean to solve the right triangle? To solve it means to find all the angles and all the side lengths. So, all right, let's go with the angle here. Anybody, what's that angle? What's the measure of that angle? What's the measure of that angle on top? 48 degrees. 48, good enough. Moving on. Okay, why? Let me do a quick review of everything. For any kind of triangle, no matter what kind of triangle it is, if it is a triangle, all the angles add up to 180. Add up the 3 add up to 180. If I know this is 90 already, then that leaves the other two to equal 90, no? So basically subtract 42 from 90, it'll give you that 48. All right, so this is 48. All right. Now, if I wanted to, okay, I have all the angles, I know all the angle measures. Now, if I wanted to figure out what this over here is, what is the length of this up and down side? And I do know the hypotenuse, because I do. And I'm standing with reference here. With reference here, which of the three main ratios am I going to use? Because they are what? Sine, cosine, and tangent. Those are the three main ones. So which one am I going to use? If I know the angle measure, we don't know y, but we do know 10. So which one am I going to use? Sine, thank you. So we can move on. So yes, it's sine. Because of SOHCAHTOA, that SOHCAHTOA thing, SOHCAHTOA, it is just sine of some angle is the ratio of the opposite side over the hypotenuse. So we do know, the only unknown is y. So I'm going to do sine of 42. Let's go with sine of 42 degrees. Sine of 42 degrees is equal to what? Y over 10. Y over 10. And really what we're doing here, I don't know if this one is going to blow your mind. I don't know if it's going to blow your mind here. What I'm going to do is that, bless you, is that a calculator has this, it has it stored. So to some decimal place. It has, because it has a ratio of any triangle, no matter how big, how small it is, that the ratio of this opposite side over the hypotenuse, the ratio of that over this, divide that length by this length, is a constant. So the calculator already knows what that is. Go ahead and put that 42, sine 42 in your calculator. Make sure it's in degrees. Make sure it says degrees right there. What's sine of 42? Are you getting 0.669? Look. All this is saying, if you're going to understand what I'm trying to teach, go over it. I'm doing it different than I was teaching in the other class. For every 0.669, this is 1. So if this 0.667 cents, this is $1. No matter what, whenever, if you have another little tiny triangle, all it's saying that if this is 42 degrees, if that is 42, like 42, no matter, this would be, the ratio is 0.699 to every 1, like that. I don't know what exactly what it is, but if you divide this by that, it gives you that ratio. That's all that's saying. Not really that hard. So this calculator has it stored. If I can go inside of the calculator, it's going to give me 0.6, what was it? Is it 0.669. It has it stored. That's all the calculator has. I don't care to be storing that in my head. The calculator can store it. And now you can just go y over 10 is equal to that. And what am I going to do? Cross multiply or something? Or multiply by 10? So what is 10 times that? Times 0.6. It's 6.69, 6.6, 6.7. It's not even that hard. It's like math, like we're so confusing. We're like, it's not even that hard. I just thought about it like this right now. The way I was teaching it in my other classes is a little different, but that's what it is. Watch. Let me explain it another way. Watch. Just for complete understanding, I hope. Look. If I was standing here, let's say I was standing here. Then now, which one is going to be? Now, okay. If I was standing here, everybody, if I was standing here, what is this? Is it opposite or is it adjacent? That's called next to. And so because I'm standing here, I'm not going to use sine because sine stands for SOHCAHTOA, opposite or hypotenuse. I'm going to use cosine for adjacent or hypotenuse. Whoa, blows my mind. But then what's the angle that I'm standing on? I'm standing on what? 40 what? 48 degrees? Yes or no? 48 degrees. So I'm going to use what? Cosine of 48 degrees. Cosine of 48 degrees is y over 10. Put that in the calculator because I don't care to memorize that in my head, but what the calculator, that's what it does. Calculators memorize things. 0.669. 0.669. $6.7. In any case, so we found y. So we found y is that. And what would be x? Let's call this x. So if I'm standing here, what am I going to use if I'm going to use x over 10? Cosine. Cosine. So it's going to be cosine of what? Cosine of 42. Ten times cosine of 42. $7.4. 7.4. That's all there's to that. Let's do some word problems here. All right, let's go ahead and copy that down. Trig word problems. In reality, this is geometry. And I'm just kind of using it to teach one little extra thing maybe that I go over. But this really was taught in geometry. I'm pretty sure it was taught in geometry already. All right, let's go. Write it down. So problem number 1. A ladder is leaning up against the wall. Okay, there's the wall. There's a ladder. A ladder is leaning up against the wall. The top of the ladder is 12 feet from the up the wall, from the ground. The bottom of the ladder is 5 feet away from the wall. How long is the ladder? Anybody? Before I even do anything, and what? If you guys are copying it down, how would you solve this? Anybody? By using what? Pythagorean theorem is correct. That is the obvious way, and that's the way I have it in the PowerPoint. But I'm not going to go ahead and do it that way. So you can learn and really understand what the heck is going on with sine, cosine, and tangents. Let me do that. Watch. Let me tell you how everything is. Math is. Everything is okay with it. Let me see. Here's my another extra little thing that I want to go over that was also supposedly taught in geometry. A better question. It's not even that. It's actually part B. What is the angle here? That's a better question. That's something else. What would be the angle theta? That's a good question. But first of all, what ratio should I use? Let's go. You guys are writing this down. I know we're going fast, but I wanna. All right. With respect standing here, let's say with respect standing here, what is 12? What is a 12? Opposite. This is called the opposite, and this is called what? Adjacent. So am I going to use the ratio that is sine, cosine, or tangent? Tangent. So, this is not just something I like to say all the time. It's just because I have no memory. I have really bad memory. It helps me to say S is the opposite or hypotenuse, cosine is adjacent. So tangent is opposite or adjacent. Okay, opposite. That's tangent. I'm gonna use tangent. That's the only reason why we have SOHCAHTOA. All right. So I am gonna do tangent, and let me go ahead and do tangent of that angle theta. So I'm gonna do. I haven't answered this question. I will answer question A in a minute. So I'm gonna do this tangent of theta that I don't know what that angle is. Is equal to 12 over 5. Okay. Now, I want to know what theta is. I want to get theta by itself. So I need to get rid of tangent. I can't just erase it again, because that wouldn't be math. And quickly, I'll go, hey, x plus 2 is equal to 5. Oh, man. Lucky it's not here. So anyways, how do you find x? How do you solve for x here? Subtract 2 from both sides. Yes or no? Your brain just spits it out, doesn't it? You're like, I don't know, subtract 2. Why? Because you know it. You're like, how do I know it? Because you've done it 1,000 times already. Probably the same x plus 2, or I don't know, you've done it too many times. Somebody says, what is 5x equal to 20? What do? Divide. Your brain just says it. You're like, I don't know, divide. So it's an inverse operation. Inverse operation. Now, what would be the inverse operation of tangent? Let me just give it to you. The answer is this. Theta will equal to tangent inverse. So I'm supposed to put a tangent inverse. It cancels with this, which I don't want to do. But then the tangent goes away if you do tangent inverse on the other side. You're going to get a calculator. If you don't have a calculator, come up and get one. Make sure it's in degrees. Make sure it's in degrees. Right at the bottom says degrees. And go ahead and do tangent inverse. Or you're going to have to go second tangent. So you can get tangent with a little -1. Yep, I got it. And then do 12 divided by 5. What are you getting? 67.3. Everybody get a calculator. I'm telling you. Come up and get a calc. I'm not helping you when you're taking the test. Approximately. Okay? So now I have found what the angle right there is. Now I'm going to solve this triangle, the length of the ladder. And let's call it L for ladder, or C. Let's call it C. If I wanted to use cosine here, I would go cosine of 67.3, which that is stored in the calculator, is the ratio of what over what? Cosine. Come on, cosine. 5 over C. Adjacent over hypotenuse, 5 over C. And we're just going to use this that is stored in the calculator, whatever that is. What does cosine 67.3 is? .3859, whatever, yes? Which I'm not going to do it that way. The way I'm going to do it is this way, okay? Let me erase that. I just want to keep it the way it is, safe in the calculator without me rounding. I want to use all the numbers. So now I gotta solve for C. Maybe multiply by C here, multiply by C here. So cancel. So I have C times cosine 67.3 is equal to 5. Now how do we get C by itself? Divide by cosine 67.3. Okay, now let me see if you can spot another pattern here. Anytime you have something like this, when you have cosine equal to a fraction, you can just switch the cosine, go where the C is at, and the C bring it back where this is at. Switch these spots without doing all the work I just did. Yes or no? You see what the final result was right here? C is equal to 5 over that, no? Yes, yes. All right, now go ahead and get C equal 5 divided by cos 67.3. Calculate it. 5 divided by cos 67.3. What are you getting? 12.956. It's pretty off, man. That's pretty off. It should be the answer. What do you think the answer actually is? The problem is that because we rounded here, this angle is rounded, 0.3. The answer, so actually for C should be 13. Let's use sine. Let's use, this is 67. See, here it goes about the rounding part. Sometimes messes it up. So what if I use sine? What would be sine of 67.3 of this particular thing? It would be what? 12 over C, no? Well, 12 over C, we don't know what C is. Man, we're trying to figure out what C is. 12 over C. What did I say about that little trick, no? Just switch. C is going to equal to what? So get a calculator, and what do you think is going to be the answer? 12 divided by... What the heck did I do? Sine is stupid. 12 divided by sine. It's 13. Got it? Yes or no? Got it? Like, there, so many ways to do this now. You could have done and jumped over here and then found this angle. Once you found this angle, then you can do a sine of this over that. You could have done a cosine of this over that. It would still would have given you the same answer. But other than that, why do all that? I just did that so you guys could appreciate this sine, cosine, tangent thing. But the way to do it is what? 5 squared plus what? 12 squared equals C squared. 25 plus 144 equals C squared. 169 equals C squared. Square rooted. C is equal to 13. Yes, moving on. I'm going to do one problem only. All right, hold on here. All right, there it is. X squared plus y squared plus c squared. But the ladder is 13 feet long. What is the angle between the ladder and the ground? You can use tangent of 12 over 5. Theta is equal to tangent inverse of 12 over 5. 67.4. What the heck? What did I do? We use 67.3? We rounded completely wrong in the other one when we did it. See what the problem is? If you don't know how to round, then you get it off.
Because it was
Huh?
38.
It was off by a little bit, no? See, it would have been 67.4. All right, let's go with number 2. Problem number 2. Spider-Man wants to stretch a wire from the top of a 100-foot building to the top of a 70-foot building. There are the 2 buildings right there. The buildings are 40 feet apart. How long does the wire need to be? That's it. How long does the wire need to be? And what is the angle between the wire and the horizontal? So basically, we're trying to figure out, that's a 100-foot building. That's the 70-foot building. We're trying to figure out how long, if it's straight, that is not hanging, but straight. It's straight. How long is this? I'm going to stop the lesson. You can copy it down after. Let's get going with actually solving it. Who got the answer written? Just looking at it. What's the answer? Or working it out quickly. No? Is it working it out? Would you? Let me finish this real quick here. Everybody, look up here. Look up here. I'm gonna make triangles up in the air right here. Would you agree, everybody? If these are buildings at right angles, no, these are gonna be straight up and down, straight up and down. It's like they're not linear or anything. So if this is 40, would you agree that this is what? This right here. How long is this?
40.
If this is 40, then this got to be 40. Yes. Then what is this? How long is this? 30. Because if this is 70, this is all the way to here, 70 plus another, that'll be 100, but another 30. So this is 30. So what is this? Loud. What is this? This is a 30, 40, 50. It's a 3, 4, 5 triangle. It will be 30. I think that's 30, 40, 50. That's 50. That's it. The question, that was 50. Then it says, what is the angle between the wire and the horizontal? Well, if this is going straight across like this, is this going straight across? So it's talking about, what is this angle here? What is this angle? Well, if this is going back to geometry again, do you guys remember a transversal? If these are parallel right here, these are parallel, then you got a transversal. This is called a transversal. And so this angle better be the same as this angle. This angle is the same as this. So we're going to use, if I'm trying to figure out this angle is this angle, wouldn't it be opposite over adjacent? It's a right angle, that's going to be tangent inverse. So theta is going to equal the tangent inverse of what? 30 over 40? Put in a calculator, that gives you the angle. And this angle here is the same as this angle here. That's yeah, that would be it for today.